Welcome everybody to this new webinar organized by ESPA Academy. For those who don't know me, I am Llorenç. I am the Global Product Business Support here in the commercial department of the ESPA group. Among other things, one of them is to organize trainings for our clients, subsidiaries, and distributors, and also for the personal workers from here. Today we are going to start up a CKE2 with our VFD, variable frequency drivers, Speedrive. In the first part of this webinar, we are going to do the same startup. The second part, we will manage the common failures or errors and alarms that may occur during the startup. And in the third part, we are going with you all together, collaborate with your doubts and questions. So please remember that you have to create a YouTube channel if you want to chat with us and send us these questions. And at the end of the session, we are going to cover all your questions and try to give a solution to your doubts. And now, without further ado, let's start with the startup. Some considerations before starting up the CKE. One of them, both pumps. In this case, we are going to see a CKE with two pumps. Both pumps have to be primed, so we have to fill them in with the water, so the suction cannot work dry. Anyway, our VFD Speedrive has the dry running protection, but we have to fill them and pry them. So let's plug in the booster set. Meanwhile, they are starting both Speedrive. We have to talk also with the suction side. It's important always to have a good pipe diameter. It has to be normally same size or bigger than the suction of the pump. So the speed of the flow circulating to the suction side must be around 1.5 meters per second. Shouldn't be higher, because we can create problems in the flow during the suction. And also, we have this tank, this vessel. It has to be inflated or deflated according to the duty point of the pump. Normally, it has to go below the duty point. For example, if you have 3 bars configured or set up in the Speedrive, then the pressure in the tank has to be around 2 bars, 1 bar below. And you know, to check the pressure of the tank, the manifold has to be empty, because otherwise we will be reading the pressure in the system. So normally you can leave a valve to empty the installation. Now, let's see both Speedrive. These are the initial screens in both Speedrive. This one is the master pump, and this one the slave. We have one master pump which controls all the other slaves. we can control with the master pump up to 7 slaves. So we have just to configure, to set up the master one, and this one will send to the other pumps all the orders and all the parameters, all the settings. See, in the screen we have these 3 LED lights with the line. Now it's plugged in. When the pump will be running, this light will be on, and if we have any alarm or error, the fault LED light will be on as well. Now, as both pumps are just with the power, just the line LED is on. So, how to navigate between the different screens? We just, here you can see, for example, if we want to go to configuration, we have to go down, so press down. If we have to go to manual, we can go to the right, and to go to auto mode, we would go to the left. Always it is shown how can we navigate through the different screens. For example, first configuration, the language. In this case, for this training, we will go and set it up to English. We press OK, and now the language has changed to the English language. One of the first things that we can do is go to manual and see if the pumps are turning correctly, clockwise, normally with our motors. Other motors could be anti-clockwise, but our motors turn clockwise. So if we go up, we will turn on the pump to 20 Hertz. And this is the pressure that we have right now in the system, 3.4 bar. So let's start manually on. Now the pump has a start. We have to go over the pump and have a look at the fan. Now the fan is turning clockwise. So the fan is, the motor is turning properly. So we have finished this part, and we can turn off the pump. So our pump is turning properly. Because if it turns the other way around, the pump will work, but it will not give the pressure that we desire. For example, if the duty point is 3.5, maybe the pump will work at 1 or 2 bars. It will not give more pressure because it's turning anti-clockwise. We can do the same step in the slave pump, turn it on, have a look at the fan. As the fan is moving at 20 Hertz, it goes slow enough in order to see if it turns properly. It turns clockwise, so we can turn it off. So the test of the turning of the motors, it's finished. This is very important because the pumps will work properly. Okay, to leave this screen. And let's go now to the main settings. We go to configuration. First, we have the language. Set point. This is normally the only thing that we have to configure in a simple startup, because our speed drives come from factory already configured or set up. So we adjust the desired pressure. For example, in this case, we can go and decrease it to 3 bar. We press OK in order to save it. The pressure, you see we have 2 pressures on the screen. This one is the one fixed right now, the current pressure, and this one is the one that we are changing. For example, if I increase, for example, it's the one that it's changing, and I should press OK if I want to save it. 3 bars for now is OK, so I don't save this new one, and it's already set. Now, in order to check if it's working in the pressure that we have set it up, we can go to auto mode, and now the pressure that we read via transducer, it shows us 3.4 bar, but we have set it up at 3. So we have to open the valves, create a flow, the pressure will go down, and right now the pumps have started. And you can see pressure, it's maintained in 3 bar. The more I open the valves, the faster will go the pumps. Okay, I turn off, I close the valve, and the pumps will smoothly and slowly come back to the initial state. And now they are stopping gradually. Okay, both pumps already stopped. This is the simplest startup that we can do in a CKE2 with our Speedrives, because everything, as I said, is pre-configured from factory. But these are ideal situations that we can find, because normally maybe you have to adjust other settings. So I want to go with you and navigate now through the different screens. We will cover all the settings in order to understand what every one of them is. So let's go back to the menu, this one, configuration, English. We already talked about the duty point. This is the desired pressure that we want to maintain all the time. Stop frequency. This frequency is calculated automatically, and it's a parameter very important because it says to the VFD or Speedrive at which frequency it has to stop the pump when we have no flow or all the valves are closed. Fine adjustments, these are more advanced. Different pressure, 0.5. What is this setting? The differential pressure is the pressure where we want to decrease from the duty point. For example, the difference. If we have right now 3 bar and we have a differential pressure of half a bar, so the pump will start 3 minus 0.5 bar. It will start at 2.5 bar. So this is the differential pressure. Stop delay. This is when stopping the pump, we will have a delay of 7 seconds. So what's the meaning of that? Once we have a situation when we open many valves and we have a flow and we close all the valves, the pump will not stop immediately. We have no flow, but the pump will continue for 7 seconds in order to maintain the pressure in case we open another valve and we don't have to be starting, stopping, start, stop the pump. So we will not stress the engines and the pumps. So we can last longer the life of the pumps with this system. This is a setting that can be modified as well. Normally 7 seconds is the one that comes from our manufacturing plant. Let's continue. Reverse rotation. The first thing that we did at starting was to check the rotation of the pumps, but we can do it also here. In case of the rotation was the other way around, that it's turning anti-clockwise, we can change it here, just going through change and confirm yes or no. In this case, pumps are turning properly, so we press no, OK in order to save it, and we can continue. Once changed, if it's the case, we can check over here. We don't have to go out and go up again. We can check from here the turning of the pump. Pressing on to start the pump. Now, I don't know if you can hear it, but the pump started. We can have a look again. The pump is turning clockwise, so it's okay. We can turn it off, pressing here. Okay, and we leave this screen. And we can continue with other. Auxiliary pumps. Okay, from now we have set up the parameters for the booster set and mainly the master pump. But now we are going to see the settings of slave pump. This is a slave pump or auxiliary pump. Adjust. Frequency on 45 Hertz. What's the meaning of this setting? So, you know, the pumps, for example, here are set up for working at maximum 50 Hertz. This is the frequency that we have from the electric lines. So what's the meaning? A pump, when it's working to 50 Hertz, it works at its maximum speed. But normally, we don't want to reach the maximum speed because pumps are more stressed and working at lower frequencies. So what's the meaning of 55 Hertz? That one pump will go maximum at 45 Hertz before starting the slave number 1, 2 or 3. So if we cannot maintain the pressure, so at 45 Hertz we'll start the second pump, and both pumps will balance the system, the pressure. And once both pumps arrive at 45 Hertz, then from there up will increase, if it's necessary, up to 50 Hertz, but just in the last scenario. So with this solution, normally we will never reach, or almost never, the maximum speed of the pumps, so we can prevent them from premature damaging. Let's continue. Delay. This is just a delay for when we reach the 45 Hertz that we have seen, if we want a delay or no. Hysteresis off. This is a setting that normally is set up by default at 0. It's just the gap between the stop of the master and the slaves. And the same, we always can introduce a delay if it's desired. So these are the 4 adjustments or settings variables that we can do with our auxiliary pumps. Let's continue. Factory settings. Okay. In the case that we have been changing the settings or parameters and we don't remember how it was before, so we can go back to the initial configuration. But you have to have one important thing in mind. Factory settings are always the same. What I want to explain right now, that for example, we have these pumps of this booster set are a multi 25-4, but the factory settings come from a multi 35-6. So if we reset, we will have to check the 2 or 3 main parameters of each pump and introduce them properly. For example, let's do a reset, and I will show you what we have to do once reset the factory settings. Okay, we press OK. We confirm, yes, press OK again. And now we have gone directly to the language. Why we go directly to the language? When we are advanced users, we can go directly to the factory settings. And how can we go to this hidden menu? Because it's a hidden menu, not everyone has access there. So we can press left and right at the same time during 3 seconds, and we will go directly to the advanced settings. Transfer to slave. Yes, that means that the master will transfer to the other slaves all the settings. Just in very specific context, we can press no, but normally we want just to configure one and send them the information to the other slaves. Motor frequency. Here we have 50 Hertz, but if in your country the lines are at 60 Hertz, so we have to set it accordingly. Maximum height of the pump. This is something very important, and this information you will find it in the body of the pump, in the plate. For example, in a multi 25-4, that is the pump of this training, it's 58 Hertz. 58 meters. 52. Have to leave it. Very important, because then with the maximum height the stop frequency is also calculated. Okay. And as you can see, the one from the left has changed to 58 meters. Let's continue. Maximum current of the moment, or maximum intensity, 11 amperes. This is also found in the plate of the motor. For example, in this case, this is too high, 11. The plate indicates us to go to 3.6, so we will leave it accordingly. This is also a very important parameter because it will prevent the motor from going over the maximum current. And press OK. Save it. Let's continue. Transducer 10 bar. This is okay. We can use a transducer of 16 or 25 bar just for the pumps that give more than 100 meters high. We will leave it at 10, how it was. 3.5 bar duty point, we can leave it at 3 as before. Frequency stop, this is calculated automatically. Number of pumps installed, 1. If we leave it just with 1, it will not communicate with other pumps. In this case, it's a 2 pumps booster set, so we have to leave it accordingly at 2 and press OK. And the system automatically saves all the parameters. So you see, just with 3-4 parameters, we can leave the pumps already set it up. And now we can go to auto mode again and create a flow. We open the valves, and here again, as you can see, and it will maintain the pressure all the time. Open the valves, both pumps. Close the valves, so the pumps can stop gradually, both pumps. And maintaining the pressure at 3 as it is set it up, both pumps. So we are almost done with the startup of the pumps. I just want to check with you the more advanced settings, as some of you already questioned. So what are the meaning of them? This is the very advanced. Go to menu, configuration. Oh, sorry, yes. I will leave it the English. As we did factory reset, it turned to Spanish. Beg my pardon, so we'll leave it at English, okay. And go back to the advanced settings. Advanced settings, here. These advanced settings are just also for advanced users, and they are protected by a password. There are two types of password. We can press 3 times left, and we will go to the counters, the historic counters and alarm counters, so we can reset them. In case of a replacement of Speedrive, it is very recommended to do this reset in order to balance the number of hours of the Speedrive, and we will have a good alternative. And the second password is to press 3 times right in order to do the very advanced settings. Okay, so we press right, right, right. Okay, and we will go directly to the constants. Here we have 2 constants. Okay, we are talking about system control. System control, you can see it in many different applications, not just for engines, also for temperature control. Probably in your house you have a monitor of temperature. Once we reach a temperature, so there is always a system control in order to increase or decrease the temperature. So it's the same with VFD. So we have to maintain a pressure. And how a VFD exactly works. So in this case, we have set 3 bars, if you remember. But how the VFD knows that we have 3 bars? So thanks to the pressure transducer, place it over here. So this part sends electrical information to the speed drives, so to say it and read the pressure in the system. So, for example, if there is no pressure in the installation, the pumps will increase the speed. The more flow we have, the pressure will go down, the transducer will lead this leak of pressure and will communicate to the speed drive to increase the speed. And this constant is to indicate how fast we can reach the desired duty point. If we increase the constant, we will approximate faster to the duty point. But there is a drawback in that if we go too fast to reach the duty point, we can overpass it and we can have oscillations, and we can have an imbalanced system. Contrarily, if the constant is too little, we will go maybe too slow. So this type of constant are just to be set in a very specific context, very specific installations, where maybe we have a different inertia and it's interesting to go slower or faster. But these are parameters that we recommend not to manipulate them. And if you have any doubt, don't hesitate to ask us. So this would be the constant Ke for the narrow band of frequencies, and we have this constant Ki for the wide band of frequencies. In between, every constant has the step. What is the step? This is just the frequency of reading. How often does a transducer read? So every 3.003 milliseconds. If we press, for example, 4 milliseconds, it will go slower. If we press and we go to 0.02, it will go faster, but it's the same. The faster we go, maybe we have more oscillations, and the slower we go, the system is probably more balanced, but it will go too slow to reach the desired duty point. A step for the white band. And the frequency of PWM. What is the PWM? This is the pulse width modulation. This normally for our motors is recommended to be at 7.5 kilohertz. If we decrease this value, we will hear a noise. So the conversion of the direct current to alternating will be not proper. If we go too high, maybe if we go too high with the frequency of pulse width modulation, the Speedrive will go faster during the modulation, but maybe we will catch temperature. The temperature of the module will go too high and can be problematic for the frequency driver. As well, if the frequency is too high, maybe we will have electromagnetic interference. So this is also a setting that it's better not to manipulate, but if you do exactly what you are doing, or you can talk it with us, we can solve it. And the stop factor. What is the stop factor? 50%. This is the factor where the pump, in case of dry running, will stop. For example, imagine you have no pressure because the installation is empty, we are running dry, the intensity will go down, and when we reach the 50%, the pump will stop. This is very important to protect the pump. In case the pump is not stopping, we have to increase this value or check the maximum intensity of the pump. And these are the advanced settings. So until now, we more or less finished the first part of this training, and let's see now how can we replace Speedrive and which are the... Okay, we will see now two questions from our team. We will try to cover them. Okay, our colleagues from Kazakhstan ask us about the reverse rotation. I will say to you, if on Speedrive master parameter of manure transfer to slave is yes, then reverse rotate on all speed drive, slave not work. Yeah. And reverse rotate on a speed drive master work, and rotate change on all speed drive in booster set. This is inconvenient if you need to change the direction of rotation of only one pumps. Now, normally when you reverse the rotation, it's just in one pump, because every pump is connected differently. So we will have to reverse rotation on all the pumps. Okay. There is another question? No? So let's continue. I will turn down the current of the slave pump so we can see the insides. We have to wait some minutes in order to the relays and the capacitors lose all the energy. I cannot, it's better not to open now the speed drive because it's a little bit dangerous. Okay. We have still current. I will right now take advantage to see. Okay, it's already turned down, so we can open it. So this is the inside of a single phase speed drive, single phase in, 3-phase out. And which are the parts when we replace the speed drive, we have to have it into account. Very important. This blue piece over here, these are the micro switch, and it's very important because it indicates us if the pump is master or slave. In this case, the position 1 is on, so it indicates is slave number 1. If normally it comes with this. All the micro switch are off. If you buy a new speed drive, it will come like that. But if you have to replace slave number 1, it has to go accordingly. The positions of the micro switch are all covered in the different manuals that we will send to you. There is a manual of compatibility. So we will leave it at 2. If I open this one, for example, number 1 and number 2, it will indicate that it's the slave number 3, for example. And if I move the number 4 micro switch is to indicate that we are working with a speed drive from the old ones. So the new speed drive, that are the yellow ones, communicate perfectly with the old ones as far as we configure correctly the number 4 micro switch. We will leave it back as before. Okay, sorry. And which other parts we have in a speed drive then? The USB connector. What is this for? This USB, it wasn't before in the older versions. In these yellow speed drives, is always here. This is to update the firmware. Okay, it's the only purpose. And how can we do it? We have to turn down the speed drive, connect a USB, and turn on the speed drive and wait for about 5 minutes approximately. The pen drive can contain only the updates for the Speedrive. It cannot contain other files because we can cause the Speedrive update to cause failure or mistake. Once it's updated, the LED will start blinking and the update will be finished. And we can turn down the Speedrive and turn down the USB to remove the USB. Other important part is this plate from here. You can see this one. I will remove it. This is the Modbus and we can install it here. Okay. The Modbus plate is in order to communicate. It's very important. I think you can buy it from last year, and the Modbus serves to read all the parameters that are occurring right now in the VFD. So before it was something that you have been asking for many years. Now it's already here that you can read via Modbus all the parameters, errors, pressure, the state, if it's running, which kind of errors, is all specified through via Modbus. So via RS485 with a USB converter, you can read all the signals from your computer. And these are the main parts, the most important in the Speedrives. So give me a second, I will connect again the Speedrive here. And turn it on. The other one is on. So now in this second part we wanted also to talk with you of some errors or some of the common failures that can occur during a startup. And one of them, in many installations, one of the most important, is not the error that appears in the screen, but it's an error that can damage the pumps. And this is when the pump is not stopping. So maybe we have all the valves closed and the pump starts and the pump continues to maintain the pressure but not stops. It doesn't respect the delay of 7 seconds and it can go infinite. So how can we solve when the pump is not stopping? So we can go easily to configuration, and this is the important setting that we were talking before, the stop frequency. If the pump is not stopping, is because the frequency stop is too low. So we can configure it manually. For example, now it's at 34 and we can increase it, for example, to 1 Hertz and press OK. Now it's at 38. And now we have to do the test in the installation. If we open all the valves, the pumps are starting, and then we close all the valves and the pumps will not stop. So we have to repeat the process and increase 1 Hertz from 1 Hertz. So we have to go up slowly because we cannot add maybe 5 Hertz because then the VFD will stop prematurely. So one by 1 Hertz up. This is the process that I would do or that we recommend. Okay. Now we have this symbol that indicates that we have to do it manually. So this is one of the most important things that we can check during a startup, that the pump actually stops. And the other common error is the dry running effect that we have already covered in the advanced settings. We have to check that the stop parameter is okay set at normally 50% of the intensity, and if the pump will not stop when we have no pressure, that it's running high, we have to increase this value. So we can leave it now to configure. If you remember, we will go again to the advanced settings. Okay, 3 times right. Okay, constants. And the stop factor is set at 50%. If it doesn't stop when it's running dry, so we have to increase it 5% by 5%. Okay, and go back. Auto mode. So until here, I think that's everything for the startup. Now, I don't know if we have any questions from you, so we will cover them right now. Okay, our colleagues ask us, stop by dry running, the algorithm for determining this error. It's correct. When the pressure is 0, so we have no pressure, and the stop factor is at 50%, it means that the intensity has to go below the 50%, that's the one that it's set up in the factory settings. So, what's in a real example? If we have 4 amperes, so the factor setting says us that it has to go below 2. So in this case, the pump will stop. If the intensity is too high, then it wouldn't stop. And the second one, the USB only for update. Yes, for us and for the users, the USB it only serves for updating the firmware. We doesn't give other use right now to the USB connector. Something else? No? So, okay, another colleague asked us which is the minimum diameter of the pipe suction. So the minimum diameter is the one calculated in order not to go over this 1.5 meters per second in the suction. So the speed of the flow doesn't have to be too high in order to work properly. Another question, what can we do to solve the phase-in error? Okay, so in the phase-in error, good question, sometimes we have the phases, in a 3-phase Speedrive, the phases are not balanced. Maybe we are in an industry and they use one of the 3 phases to different loads, so the one phase is stressed and once arrive to the speed drives, they are in balance. Maybe one phase has 400 volts, but there is one that has 350 because it's too charged, too stressed. So the difference between the phases is unbalanced, so the speed drive will recognize it as an error and it will not work. So how can we solve it? Then we have to check in our industry that the three phases are balanced. Maybe we have to discharge one of the phase and use another one. So we have to be in the voltage allowed. Normally with 20 volts difference it works. So I think there's no more questions, so we will conclude this first webinar. I want to give a thank you for being here with us and for your collaboration, your questions. Thank you very much. We hope to continue with more videos in the near future. I want to acknowledge and give a very special thanks to all the team that has made possible this webinar. These are the team from Digital Transformation, Javier Rubio, Josep Oliver, Sergi Planas, Jaume Gullet. Thank you to all of them. Without you, wouldn't be possible. Also to our designer, Deli Martinez. Thank you very much, Deli, from the communication department. Also the head of it, David Way. Thank you for your help. Also, Toti Planas from the Servin. Many of you already know him. Thank you very much for always your support. And I cannot forget also the maximum organizer of this event that has coordinated everything to it. And thank you very much to our Chantal. So, thanks to you and see you in the next video. Goodbye.